learners! Welcome to another Math 2 class with Teacher Marian. This time, we will discuss the second lesson in Quarter 4, Module 1, which is quartiles.
The concept of quartiles is an extension of the median. The quartiles are the points that divide the distribution into 4 equal parts. In other words, these are the values that divide a list of numbers into quarters. A quartile divides a sorted dataset into 4 equal parts so that each part represents 1/4 or 25% of the dataset. Each set of scores has 3 quartiles. The first quartile, also called lower quartile, is defined as the middle number between the smallest value and the median of the dataset. Next is the second quartile, which is the median of the data. And the third one is the third quartile, also called the upper quartile. It is the middle value between the median and the highest value of the dataset. Again, Q1 is called the lower quartile and Q3 is the upper quartile. Q2 is greater than Q1 but less than Q3, where Q2 is the median. The difference between Q3 and Q1 is what we call the interquartile range. We can say that 25% of the data has a value less than or equal to Q1. 50% of the data has a value less than or equal to the median or Q2, and 75% of the data has a value less than or equal to Q3.
Now, let us move on to finding the quartile value for ungrouped data. Since the second quartile is equal to the median, the steps in finding the median are the same as the steps in finding Q1 and Q3. There is no argument on picking up the Q2 value as it is known to be the median of the data set. So going back to the steps in finding Q2 or median, first is you are going to arrange the values in the distribution in ascending order, meaning in increasing order or from least to greatest. Then, find the value of Q2. Remember, if there is an odd number of data points, find the center data point. And if there is an even number of data points, find the center gap and average the numbers on either side of the gap. So when you have 5 data sets arranged in ascending order, in which 5 is odd, the third value is the median. And when you have 6, which is an even number, the average figure of the third and fourth value is the median. However, confusion starts to reign in when we try to decide the cutoff values on Q1 and Q3. Upon scouting around textbooks and software on statistics, it is amazing to find many different conventions and methods to decide on Q1 and Q3 values. Different methodologies produce may slightly varied quartile results, and they may affect the final outcome on the data analysis. So in this quarter, we will be making use of one method in finding measures of position or quantiles for ungrouped data to be able to arrive with the same answer. William Mendenhall and Terry Sensich developed the steps to find the position of the quartile in the given data. So in using Mendenhall and Sensich method, you need to follow these steps. Step 1. Arrange the data in ascending order. Step 2. Find n or the total number of elements. Step 3. Calculate the position of quartiles using the formula Qk is equal to k over 4 times the quantity of n plus 1, where Qk is the indicated quartile. K, which could be 1, 2, 3, because in a quartile, each set of scores has 3 quartiles, Q1, Q2, and Q3. N is for the number of cases or scores or data. Take note that the resulting value must be rounded to the nearest integer. However, if the resulting value falls halfway between two integers or has a decimal part of 0.5, you have to follow these rules. Round it up if the indicated quartile falls on the left side or less than the median, and round down if the indicated quartile falls on the right side or greater than the median. So for example, the resulting value of the position of Q1 is 3.3. The computed value 3.3 becomes 3 after rounding to the nearest integer. If the result is 4.9, then round it to the nearest integer, which is 5. However, if the result falls halfway between two integers or has a decimal part of 0.5, locate first where the indicated quartile value falls in a distribution in order to decide whether to round up or round down the resulting value. If we have the position of Q1 is equal to 6.5, then we have to round it up to 7, since Q1 falls on the left side or less than the median. And if Q3 is equal to 5.5, then you have to round it down to 5, since Q3 is on the right side or greater than the median. For step 4, look at the arranged distribution. So you have to look for the value of the resulting element in step 3 in order to find the indicated quartile value. So now let us proceed to the example. Using Mendenhall and Sinsich method, find the first quartile or Q1 and the third quartile or Q3 given the set of data 1, 3, 7, 7, 16, 21, 27, 30, and 31. For the first step, arrange the data in ascending order. Since the given data is already on its ascending order, so we will not anymore arrange the observations. Step 2. Find n, or the total number of elements. By counting the number of elements in the data set in step 1, we got the value of n, which is 9. Step 3. Calculate the position of quartiles using the formula qk is equal to k over 4 times the quantity of n plus 1. For Q1, locate its position using the formula 1 over 4 times the quantity of n plus 1, as we substitute 1 to the value of the variable k in the formula. So we have the position of Q1 is equal to 1 over 4 times n plus 1. Substitute the value of n in the formula. So we have here 1 over 4 times the quantity of 9 plus 1. So 9 plus 1 is equal to 10 times 1 divided by 4. The resulting value is 2.5. The computed value 2.5 becomes 3 after rounding up. Therefore, lower quartile value or Q1 is the third data element. Now, let us look at the third element in the data set in step 1. We can see that the value of the third element is 7. So, Q1 or lower quartile is equal to 7. Similarly, position of Q3 is equal to 3 over 4 times the quantity of n plus 1. Substitute the value of n, which is 9, so we have 3 over 4 times the quantity of 9 plus 1. 9 plus 1 is equal to 10 times 3 divided by 4. So we will arrive with an answer 7.5. The computed value 7.5 becomes 7 after rounding down. Therefore, the upper quartile value or Q3 is the seventh data element. Let us look at the seventh element in the data set in step 1. We can see that the value of the seventh element is 27. So Q3 is equal to 27.
And that's all for this lesson about quartiles for ungrouped data. Maraming salamat sa panunood, mga kaalamat!